we're given that 7 plus 4 root 3 whole raised to the power n is equal to p plus beta, where p is the integral part and beta is the fractional part. Since beta is a fraction, therefore it is strictly greater than 0 and strictly less than 1. Now consider the number 7 minus 4 root 3. Root 3 is approximately equal to 1.7, therefore 4 root 3 is approximately equal to 6.8, and therefore 7 minus 4 root 3 is greater than 0 and strictly less than 1. Therefore, 7 minus 4 root 3 whole raised to the power n, where n is an integer, is also strictly greater than 0 and strictly less than 1. Let's denote 7 minus 4 root 3 whole raised to the power n by f, and therefore f lies between 0 and 1. Now consider the number 7 plus 4 root 3 whole raised to the power n plus 7 minus 4 root 3 whole raised to the power n. Expanding both terms using binomial theorem, we get 7 raised to the power n plus n choose 1 times 7 raised to the power n minus 1 times 4 root 3 plus n choose 2 times 7 raised to the power n minus 2 times 4 root 3 whole square plus n choose 3 times 7 raised to the power n minus 3 times 4 root 3 cube plus and so on for the first term, and the second term is equal to 7 raised to the power n minus n choose 1 times 7 raised to the power n minus 1 times 4 root 3 plus n choose 2 times 7 raised to the power n minus 2 times 4 root 3 square minus n choose 3 7 raised to the power n minus 3 times 4 root 3 cube plus and so on. Now note that the second term in the first bracket cancels with the second term in the second bracket. Similarly, the fourth term in the first bracket cancels with the fourth term in the second bracket, and so on and so forth. And also note that all the other terms in the first and the second bracket are the same, and therefore this expression reduces to 2 times in brackets 7 raised to the power n plus n choose 2 times 7 raised to the power n minus 2 times 4 root 3 square, which is 48, plus n choose 4 times 7 raised to the power n minus 4 times 48 square, plus and so on. Note that the expression in the bracket is an integer, and 2 times an integer is an even integer. Therefore, the value of this expression is an even integer. Now 7 plus 4 root 3 whole raised to the power n is p plus beta, and 7 minus 4 root 3 raised to the power n is f as assumed above. Therefore, p plus beta plus f is an even integer. Subtract p from both sides, we get beta plus f is equal to an even integer minus p, which is also an integer, and therefore it follows that beta plus f is also an integer. But we know that beta is a proper fraction, therefore lies between 0 and 1, and so does f. Adding the two inequalities, we get beta plus f is strictly greater than 0 and strictly less than 2. But we've just established that beta plus f is an integer, and the only integer that lies between 0 and 2 is 1. Therefore, beta plus f must be equal to 1. It therefore follows that 1 minus beta is equal to f, and f is equal to 7 minus 4 root 3 whole raised to the power n as assumed above. Therefore, the product of 1 minus beta and p plus beta is equal to 7 minus 4 root 3 whole raised to the power n multiplied by p plus beta, which is equal to 7 plus 4 root 3 raised to the power n per the problem statement. And this is equal to 7 minus 4 root 3 times 7 plus 4 root 3 whole raised to the power n. And this is equal to, in brackets, 7 square minus 4 root 3 square whole raised to the power n, which is equal to 49 minus 48 whole raised to the power n, which is equal to 1. Therefore, 1 minus beta times p plus beta is equal to 1, which is the required result.